Hello, and welcome to the Rice Robotics Club Robo-Tutorial. In this series of videos, I'll be showing you how to do the design and how to build your own robot using Onshape CAD. So the robot we'll be building is a robot arm that looks like this. It has 1 degree of rotation here, where this entire plate will rotate, rotated by this motor. Then we have 2 servos up here that will each rotate the first and second link of the arm, allowing it to move around. Finally, we have an ultrasonic sensor attached to the end of the arm that will allow us to do interesting things with the programming of this robot. So if you're totally new to CAD and robotics, don't worry, we'll be taking it slow in the beginning. I'll make sure to show you exactly how to do every step of the process. If you're more experienced with CAD but you still want to build a robot, keep an eye out for small design improvements that you can make to the bot to make it your own. Or if there's anything you want to personalize in the design as we go along, feel free to do so, if that will let you get more out of this experience. So we'll go ahead and start by working on the CAD for our first part, which is the base hub. The base hub is the central body of the robot arm. It will contain all the electronics in this area. It has a central axis, which is where that top base plate will rotate. And that has a slot for the motor here that's responsible for that rotation. So we'll hop into a new Onshape document. Whenever you open the new Onshape document, it'll always create a part studio and an assembly for you to mess with. They're both blank, and they're both contained in the file select down here, which is the section where all of our parts, assemblies, and folders will be stored as we add more files to this document. File select. And then in this area, we have the workspace. This is where all of our sketches and features will actually appear as we create them. We automatically have the origin and then 3 reference planes here, so that we can start by creating first sketch, which we'll do in a moment. Over on the left, we have our feature tree. You can see that the origin and those 3 reference planes are already listed here. And any other sketches and features that we create will also appear here. That's how you can see all of the different bodies and drawings that make up our part. Here is the feature toolbar. It has a bunch of different tools that can be used to create all sorts of different parts in Onshape. We won't touch all of them in this tutorial, but we'll touch as many as possible. Then over here we have a tool that allows you to change your view of the part. You can click a face of this cube to view normal to that cube, or normal to that face of the cube, or you can select a corner to get more of an isometric view. And you can also use these arrows to slightly rotate the view as necessary. There are some other tools in this interface. Those are the main ones that we'll use, and if any others come up, I'll explain them once we need them. So let's start the CAD by creating our first sketch. Go up to the top left and click the sketch button. And whenever you create a new sketch, the first thing you need to do is decide what plane that sketch will be on. In this case, we want to create a sketch on this top plane. So select the top plane, and now a sketch has been created. Now, one tool that we'll use a lot is View Normal to Sketch Plane. If you right-click and you look at the bottom of this box, you see View Normal to Sketch Plane. That will automatically reorient our view to the view that is most convenient for creating a new sketch. So always right-click and View Normal to Sketch Plane. So the first thing we're going to draw here is a circle centered at the origin here. So go up to the sketch toolbar, click Center Point Circle, draw a circle centered at the origin by first clicking the origin and then clicking anywhere else to finalize the circle. So we defined the circle to be centered at the origin, so we can't move the circle around, but we can change the size of the circle because we've done nothing to specify what the diameter of this circle should be. And that's why it's blue. Whenever a sketch entity is blue, that means it's underdefined, which means there's something about it that we haven't fully specified, and so we can still move it around or change its size. So to fully define the circle, we need to add a dimension. So the dimension tool can be found in the sketch toolbar up here. Dimension. We want to apply dimension to this circle. So click the circle's circumference, then click somewhere else. And this is defining the diameter of this circle. In this case, we want the circle to have a 140 millimeter diameter. So type in 140 millimeters, click enter. And now the circle is fully defined. We can't change its position. We also can't change its size because we've specified its diameter with this dimension. So this sketch is complete. It's a simple one. I click the green check mark to finalize the sketch. So now you can rotate your view by clicking and holding the right mouse button. You can see that we've created a 2D sketch on this top plane. But we need to convert this 2D sketch to 3D geometry. And the way we're going to do that is by extruding it up with an extrude feature. So go up to the top left, right next to the sketch button, there's an extrude button. Click that button, and it's going to create a new extrude feature. So the first thing we need to do is tell the feature what sketch face we want to extrude. In this case, it's just going to be this circle. So select the circle. You can see it automatically extrudes it upward by 25 millimeters and turns it into a 3D shape, a cylinder. So we want to specify this height to be some other value. In this case, it's going to be 49.3 millimeters. So specify the depth, type 49.3 millimeters, click enter, and the height automatically updates here. Notice that up here we're in the new section, which means instead of adding to existing geometry, we're creating a new body, which is what we want. Click the green check mark to finalize the extrude. Now, one important thing to keep in mind as we're creating our parts is in the feature tree over here, this is where the sketches and the features that we create show up. And you should always name these as much as possible so that other people, whenever they come in to read your documents, they can tell what's going on. They can tell how you actually created the part shown in the workspace here. So, at least for the purposes of this tutorial, I'm only going to name the extrudes and not the associated sketches. Normally, you should probably name both, but in this case, I'm going to name this extrude base of body and click enter to finalize. By the way, how I did that, you right click, then you select rename to rename a feature or a sketch. And while we're at it, we should also name this part studio. You right click in the file select, the part studio, click rename, and then type base, click enter. Just always remember to name the relevant parts and features in your CAD, just so whenever other people come in and try and understand it, they have a much easier time. So we've created our first feature. Now it's time to create a second feature. That starts by creating a sketch with the sketch button in the top left. And this sketch will be on the top face of the cylinder. So select the top of the cylinder to add a sketch plane there. And remember, right click and view normal to sketch plane. Our next sketch is going to be another circle. It's going to be a cutout that we make inside of the cylinder. So it'll be another circle, also centered at the origin, but it's going to be slightly smaller. So select center point circle from the sketch toolbar. Click the origin to center our circle there. Drag out a little bit, and then click to finalize the circle. Now this circle is underdefined, which means we need to tell Onshape what its diameter should be. So select the dimension tool from the sketch toolbar. Click the circumference of the circle. Click outside the circle. And this circle will have a diameter of 130 millimeters, slightly smaller than our circle from before. Click the check mark to finalize this sketch since it's fully defined. And now we're going to create another extrude feature from this circle. However, this time, instead of adding material, we're going to be removing material by creating a cutout in this first feature that we created. So select extrude from the feature toolbar. We're going to extrude this sketch that we've just created, but instead of clicking it here in the workspace, we're going to click it in the feature tree. Both work. And you can see it's adding material, but that's not what we want. We actually want to be removing material. So toggle the remove option up here. And then we want to remove material with a depth of 44.3. Just type in that value, click enter, and that will leave a 5 millimeter floor at the bottom of this cylinder, which is what we want. Click the green check mark to finalize the extrusion. Make sure to name your feature. Okay, and now that feature is complete. By the way, at any time, you can click the F key, and that will automatically fit your part to the screen and give you usually a more convenient view. Okay, now it's time to create a sketch that's not a circle. Very exciting. So, also, I will say, at this point, I may stop reminding you to do some of the more obvious parts. For example, right-clicking and view normal to sketch plane. I'll stop mentioning those things, but that doesn't mean they're not important. So keep in mind always to follow those steps so that you're creating your Onshape part in the most efficient way possible. So we're going to create a new sketch. It's going to be on the bottom face of the base. So right click and rotate your view so you can see the bottom face. And click it. Right click, view normal to sketch plane. And now we're going to be drawing a corner rectangle. So go up to the top left, select the corner rectangle tool. You can click the drop down, you can see there's a corner rectangle option, a center point rectangle option. We want the corner rectangle option, so select that one. Click anywhere to establish the first corner. Click somewhere else to draw the rectangle completely. You can see it's underdefined. It has this blue outline. That's because its size and its shape are not well defined. So it can change position and it can change size. So we're going to start by applying dimensions to set its size. It will be 25 millimeters wide. So select the dimension tool and select the bottom edge. Make it 25 millimeters wide. And then create another dimension of this other side to make the rectangle 74.15 millimeters tall. So now our rectangle is created, but we still need to fully define its position. And we're going to do that with respect to the origin here. So to start, we want to actually add a point to our rectangle. How you do that is you go up to the sketch toolbar, you select the point tool, and then we're going to add a point to the midpoint of this bottom edge. To do that, hover over the edge and scroll to the side until you see a box appear, just like that. That means you've located the midpoint. Click to put a point there, and now the point is added and it's at the correct location. The reason we want a point here is because we want to make the midpoint of this bottom edge vertically aligned with the origin. So we have a point here, and now we're going to use a relation to vertically align these 2 points. The relation tool is up here. There's a drop down, and you can see all the different kinds of relations you can make. In this case, we want to use a vertical relation. So select vertical, and now select the 2 points that you want to be vertically aligned. In this case, it's the midpoint that we just created and the origin. So it snaps into place, and you can see that these 2 side edges are now fully defined, but the top and bottom are still underdefined. That's because if you click and drag the edges here, it's still allowed to move vertically, but it can't move horizontally. So that means we need one more constraint to fully define this sketch. And the way we're going to do that is to specify the distance between the origin and this bottom edge. To do that, we're going to create another dimension between the origin and this bottom edge. It's going to be the vertical distance between the two. And we want this distance to be 33.25 millimeters. Now, the entire sketch has black edges, which means it's fully defined, and we're finished. So now we'll click the green check mark to finalize this sketch. And now I've created a 2-dimensional rectangle on the bottom of our base hub. So now we're going to extrude this rectangle all the way through the base hub, creating a cutout. So click extrude, select the rectangular face here. Now notice if I hover over, it doesn't select the whole rectangle, it only selects part of it because the rectangle is divided by this circular edge. So either I can click both of these faces to begin to extrude them, or I can just select the sketch from the feature tree and it automatically selects all faces of the sketch. So once again, it's automatically adding material, but we want to be removing material. So click remove. And in this case, instead of specifying the distance we want to cut, we just want it to cut all the way through the base hub. So right here, where it says blind, that's where you can select an end type. Instead of blind end type, we want to use a through all end type. So click through all, click the green check mark, and now our cut has been added. So this is the beginning of where our motor will sit in the final design. So create this cutout, but now we need to actually add another extrusion that's actually going to be the same sketch, this time adding material. So to accomplish that, you can see our sketch is now hidden since we've already used it for an extrusion. To unhide it, come over here, hover over the sketch, and click this eye, and it will unhide it, and you can see it again. Also, we should make sure to name this extrusion. Okay, now we're going to create another extrude feature from the same sketch as before. This time I'll just select both faces. And you can see it's adding material, which is what we want. But I want it to be adding material in the opposite direction. So how you do this is you go over to the end type and click the opposite direction tool. And it'll automatically flip directions there. Now you can also see that this extrusion is gray instead of blue. And that's because we've decided that we want to create a new body rather than add material, which is not what we want in this case. We want to be adding material to this cylindrical body. So click Add in the Extrude dialog box, and now it turns blue. We're just adding to this existing geometry. So we want to extrude this rectangle up with a depth of 18.7 millimeters. Click the green check mark to finalize the sketch. Now we have the beginnings of our motor platform here. So the next step is to create a cutout in this platform that will help the motor to sit there. So we want to create a new sketch. It's going to be on top of this motor platform. Make sure to reorient your view. Now we'll be drawing another corner rectangle. So select the corner rectangle tool from the sketch toolbar. Make the first corner coincident, meaning that it lies on this top edge. Make sure it's coincident, but make sure you don't place it at the midpoint, because that adds a constraint we don't want. Just make sure it's coincident somewhere else on the line, and then make the other corner coincident at some point on the bottom edge. I'm just going to do mine over here. Okay. Great. And now we should probably make sure to hide this sketch from before as well. So now you can see the top and bottom edges are fully defined, but these blue edges are still underdefined. And that's because we can drag them left and right. We need to do something to specify both of their positions. So first, we're going to add a midpoint relation, just like we did in the previous step. Or first, we'll be adding a midpoint, and then we'll use a midpoint relation to start to lock in this geometry. So click the point tool from the sketch toolbar. We have to zoom in on this shorter edge. Make sure that you're placing a point at the midpoint of the smaller rectangle's edge and not the larger rectangles. They may be very close together, so be careful about that. So we're going to slide along this shorter edge until we see the box appear. Create a point there. And now we're going to use a midpoint relation. The midpoint relation takes a point and then a line, and then it will place that point at the midpoint of that line. So that's kind of confusing. I'll show you what it looks like. Go to the relation menu, click the drop down, select midpoint, and now we want to move this point to the midpoint of this line. So select the line, you can see it snaps into place there. So the rectangle is still not fully defined. It still has blue edges, but it at least is now constrained, so that has to be centered vertically with the origin here. So the final dimension we need to fully define this sketch is the width of this rectangle. So select the dimension tool from the sketch toolbar. This rectangle will be 8 millimeters wide. Now the rectangle is fully defined. The sketch is complete, so click the green check mark. Now we're going to extrude this down into the motor platform, removing material. So select extrude from the feature toolbar. We want to extrude this sketch face. We want to make sure we're removing material. And now we need to specify the depth of that extrusion. We're going to remove material with a depth of 9.5 millimeters. Now, for most of this tutorial, I'll just be providing you with the dimensions that worked for my design. That's because you have to do a lot of designing around existing components. For example, here we're designing around the motor that is cheap and meets like the specs for our design. So in this case, I'm just giving you the dimensions. If you're designing your own robot, then you're going to need to find those dimensions for yourself. So just know that these hyper-specific and maybe random seeming dimensions are coming from somewhere. I'm just providing them for you in this case. So we've extruded this rectangle down with a depth of 9.5 millimeters, removing material. Click the green check mark to finalize the sketch, to finalize the feature. And now we have a cutout that will help our motor sit in place. So we're not done with the motor platform. We need one more feature, which will add some supports to each of these corners that will hold the motor in place so it can't just slide out like it could now. So we're going to create a new sketch on the uppermost face of this platform, which is right here. Right click and reorient your view. And now we're going to create 4 small rectangles to provide support to the motor so that it can't slide out of the base hub. So select a corner rectangle from the sketch toolbar. Might zoom in just to make sure you're getting everything right here. Make sure your rectangle starts at the top left corner of the platform. And then the second corner is somewhere coincident with this edge. It doesn't matter where for now. So you can see this rectangle is almost automatically fully defined. The only thing that's not fully defined is the position of this bottom edge because it can slide up and down. So to fully define this sketch, we just need to define the width of this edge. So select that edge, and we're going to make it 5 millimeters wide. And now this rectangle is fully defined, and we want 3 other rectangles just like it in each of these corners. So we could just create 3 more, just as we've done here, but there's a more efficient way of doing it. First, we will actually draw another rectangle down here in the bottom left. In the same way, it'll be at the bottom left corner is where a rectangle will start, and it'll end coincident with this edge at any point. So now we want these 2 rectangles to be identical. We could simply add another dimension that establishes this width. But then if we changed one of the widths, the other one wouldn't automatically change. So instead, we're going to use an equal relation. So go to the relation menu, click the drop down, select equal, and an equal relation will always make 2 edges to be the same length. So we want this edge of this rectangle to always be the same length as this edge. Now you can see it snaps into place and the sketch is fully defined once again. So now if we change this width, something like 15 millimeters, both rectangles automatically update with the new dimension. This is very convenient because if they had their own dimensions, we'd have to update them both separately. But this way we only have to make one change to change both rectangles. So to undo that, set it back to 5 millimeter width. Now we'll use another trick to add 2 more rectangles to this section of the base platform. We'll do that using the mirror command. So the mirror command is up here in the sketch toolbar. Select the mirror command, and what the mirror command will do is it'll mirror any sketch entities that you select about some line that you specify. So in this case, there's a line made by the plane that's splitting the motor support or the motor platform. So select that, and now any entities that we select will be mirrored across this line. So for example, we're going to mirror this rectangle, and it'll appear in the top right here. We're going to click and drag, select that rectangle. It automatically is mirrored over here. Do the same with the bottom rectangle, and it's automatically mirrored over here. Now these new rectangles behave just like this one does. So if you update this dimension, all 4 rectangles change at the same time, which is great for our purposes. So this sketch is complete. Click the green check mark to confirm. And now we want to add another extrude feature, extruding these supports up. So click extrude. So if there's a bunch of different shapes in this sketch, it's going to be more convenient for me to just select the sketch I've just made instead of clicking them individually. And then we want to extrude them and add a bunch of material, but not that much material. Only going to be to a depth of 7 millimeters. Click the check mark to finalize the extrusion. And now the motor platform is complete. The motor can sit in here without sliding out, and it can provide the rotation for the top plate. Now I've lost track of my extrusions over here. I'll go through and name them very quickly. Yeah, so if you lose track of naming your features as you go, that's okay. Just make sure to name as many of them as you can as you go, just so it's more readable for people that are new to your CAD. So the motor platform is complete, but we still need to add that central axis that provides, I guess, an axis for the top base plate to rotate about. So we're going to create a new sketch. Select the sketch from the sketch toolbar. It's going to be on the bottom face or on the floor of the cylinder. Right click to reorient the view. And now it's just going to be another circle centered at the origin, just like before. So select center point circle from the toolbar, click the origin and drag out and click somewhere else. And that makes a circle centered at the origin. Create a new dimension. Select the circumference of that circle and give that circle a diameter of 20 millimeters. The sketch is done, so click the green check mark. And then we're going to add another extrude feature. Select the sketch. But in this case, we don't want to just extrude it up blindly. We actually want to extrude it so that the top face of this new cylinder is parallel to the top face of the overall base hub. So we could just figure out what this distance is and say that we want to extrude that distance, but it's more effective to use a different kind of end type, which is called the up to face end type. So select up to face from the dropdown. And now we click some face and it will automatically extrude so that that face and the top face of our new extrude are parallel. So select the top face of base hub. You can see it automatically extrudes so the two become parallel, which is exactly what we want. And now if we were to change the height of this base hub, this central axis would also automatically update, which is great. So click the green check mark to confirm the extrusion. Okay, great. So now we're going to create another sketch. It's going to be very similar to what we've seen before. Make it on the top face of the cylinder we've just created. Right click to reorient the view. And it's going to be another circle. Hooray, but a smaller circle, also centered at the origin. Just create a small circle there. And this circle is going to be a cutout into that cylinder we just created. It's going to have a diameter of 15 millimeters. Great, the sketch is complete, so click the green check mark. And then create another extrude. In this case, we're going to be removing material, extruding down. Make sure to select your sketch before creating extrusion. Goes down, and this time we will just use the blind end type, and we want to extrude down to a depth of 20 millimeters. And just as a reminder, this will provide a channel that our wires can pass through so that they can access the electronics that are sitting down here in the base hub. So click the green check mark. Now we're almost done with the base hub. Just one more feature is needed, but it's going to require us to take an additional step, which is create a new reference plane. So what we want to do is we want to create a sketch that will allow us to cut through this cylinder in this direction, sort of parallel to this right plane. But the thing is, you can't create a sketch on a curved surface. You can only do it on flat surfaces. It won't even let me select it here. So to do that, we need to create a new plane to add that sketch to, and we need to make that plane tangent to this central cylinder. So we're going to go up to the top feature toolbar. We're going to select the plane tool here. There's a drop down. We just want the plane tool. Under plane type, we want to select the tangent option. We want this plane to be tangent to this curved surface. So select the surface. You can see it adds a plane here, but that's not exactly where we wanted the plane. And it says the plane is not fully defined. We need to select another plane or point to fully orient the plane. That's because there's a bunch of different possible orientations where this plane is tangent to this curved surface. So we want it to be tangent to the curved surface. We want it to be parallel to this front plane. So select the front plane. And now the plane is fully defined. So click the green check mark to finalize the plane. Now it's kind of difficult to see. I'll hide all of the default planes so we can just see the one we're working with. There's the plane we've just created, and you can see it's tangent to that curved surface. So now we're going to create a sketch on this new plane. Great. Now we're going to make a rectangular cut out straight through this cylinder. Okay, so in this case, instead of a corner rectangle, we'll be using a center point rectangle. So click the drop down, make sure you're creating a center point rectangle. Now we're going to draw this center point rectangle so its center point is vertically aligned with the axis. You can see it automatically lines up here. It knows what we're trying to do. So make sure that you're aligned with the origin. Click to set the center point, drag out, and then click anywhere else to draw a rectangle. And if you click and drag, you can see that a vertical relation between the origin and the center point of this rectangle has been automatically created. You drag it vertically, but we can't drag it side to side. So now we're going to define the size of this rectangle. It's going to be 7 millimeters in height and 10 millimeters in width. So first, the height is going to be 7 millimeters. And the width will be 10 millimeters. You see, it's still not fully defined, and that's because it can still slide vertically. So we need to put some kind of relation or dimension to fully define the sketch. And in this case, it's going to be a dimension from the top base of the base hub to the bottom edge of this rectangle. It's going to be 20 millimeters. The feature is complete, and the reason this is 20 millimeters is because we want to align the bottom of that rectangle with the bottom of this cutout here, which had a depth of 20 millimeters. So that's how we arrived at that dimension. The sketch is complete, so click the check mark and create one final extrude feature. Select the most recent sketch, and we're going to be removing material, and we want to make sure we go all the way through this middle cylinder. And you can see it's actually already doing that, which is great. Distance here doesn't really matter because this is just empty space. We just want to make sure we make it all the way through the cylinder. So 25 millimeters works for our purposes here. Click the check mark to finalize the sketch. Name our last feature. Now the base hub is complete. And I say that there's actually one more small change we'll make later whenever we put the base hub into a sub-assembly, but for now, this base hub is complete. So congratulations, you've made it to the end of our first video in the Rice Robotics Club Robo-Tutorial, and I hope you're enjoying yourself, and we'll see you in the next one.